Hi there, this is session 17 of programming from the very basics using Python. In this video, we will continue with our string operations. I talked about working with strings in the previous session. I explained about how to create strings using literal syntax notations and some basic operations you can perform on string like concatenation and repetition and using the subscript operator to get items of a string or even extract slices of a string. So we'll continue with it, and I will also give you some introduction to some interesting string methods. First of all, so a couple of other operators I could not cover in the previous session, which I'm continuing now, are these. One of them is an old operator, which you'll still find them being used in a couple of Python programs. That is using the percentage operator. I will just cover that first. So if I just try to use something like, say, name colon percentages, and I'll just try to forgot to create a string. Yeah, I have not selected the kernel, have I? Okay, sorry for this. There's a name colon percentages and maybe score and percentage 3.2 f and followed by, let's assume I'm just going to use maybe something else. Let's say age colon percentage d. You see this format specifiers being used here. These are the old style format specifiers reminiscent of the C programming language. So if you've been working on C programming, I think I used the printf function or sprintf for the entire family of printf functions. You use these kind of format specifiers for formatting strings as a part of the function. Well, what is a function feature in a language like C and C++ and a couple of other languages is an inherent string feature in Python. So when you actually print A here, it just prints it as is without any changes whatsoever. But I can actually do this. I can now say B is equal to A percentage, open parenthesis. I need to provide a tuple, and this tuple should match exactly the number of format specifiers that you have mentioned in here, also with their types. So if I'm using a percentage %s, you need to pass a string. I think if you pass integer and others, it might work for string. But here you need to pass a floating point, and here you need to pass a decimal integer. So if I just use something like, say, John, and let's say the score is some 56.1234. I think 3.2f doesn't work. Just try to make it like, say, 7.2f. And next number, I'll just try to use, let's say, 23. If I try to print B, you get this. So what it really does is the percentage operator, if one of the operand is a string and the other operand is an iterable, I use the word iterable, so it can be a list, it can be a tuple, or any other collection, or any other iterable, as long as they provide exactly these many items as required by the format specifier, not more, not less. Otherwise, they'll throw an error. If I try to pass maybe another extraneous number, it throws an error. You can see that. Or if you have one number lacking, even then you will have an error. So if you miss a number out, you'll still get an error. So you need exactly that many items in the right hand operand here. If it's a tuple or a list, or maybe a set. Set might not make sense because it's unordered. You just will have a problem with choosing the formats, right? Mostly you'll have a list or a tuple, preferably, and you actually pass these arguments and then they work. Mostly people will use it directly in print function, so you could use something like, say, print a percentage and just pass on a tuple, where you could use something like, say, Mary and 45.67, and let's say some number, let's say 32. It works. So this is the old printf style format specifier supported as a part of a string object using the string format operator. This is a string format operator. Now this is no longer very popular since Python 3.0, because in Python 3, they introduced, first of all, in Python 3.0 onwards, they introduced a method called format method, which seems to be a better successor than this notation. So consider this use case. Let's say I have a string that shows up a message like this. Let's say it's a message, but I want to say maybe it's a greeting message for a hotel or place like that. I say hello percentages, welcome to percentages. Let's make it a multi-line string. Yeah, let's start with it first. I say percentage S is a great place to visit. See around percentage S. Let's say this is a kind of a message template, if you prefer, where I want to substitute some of these format specifiers with the name of a guest to a place, maybe a hotel, and the name of the hotel for another format specifier. If you want to make it work, you need to try out something like this, where you'd say maybe print msg percentage open parenthesis, then maybe the guest is, let's like to use them as a variable here for now. Let's say guest comma hotel is equal to, let's try some name, let's try Alice, and let's use a hotel as a hotel in India, so let's assume Taj, right? I'll say Taj Hotel. So here I need to use it like this: guest hotel hotel guest. You can see it's sort of very repetitive. This template is not very intuitive, and you need to repeat it all over. The moment you learn how to use format method, things get more simpler. With the format method, all you can do is just use a placeholder like this, curly braces, and you can put a number. I'll put a number as 0 for now. Okay, 0. And I'll just say welcome to 1. And I could type 1 is a great place. See you around 0. And now this time, assuming that guest is Alice and hotel is Taj Hotel, instead of using the format operator, I could rather use msg.format, a format method, format of. I could rather use guest as the first parameter and hotel as second parameter. Maybe you can also pass the actual values there. I can just type format of Alice, comma Taj Hotel. So I can do that. And this works just fine. So you can see that's more concise than using the format operator, which is the old school way. If you live in the Python 2 era, I think that's the only way you would actually have to format. But with Python 3 onwards, there's a format method which does a much better job at string formatting and format substitution or template substitution. You could also improvise. You can make this message more intuitive, where you can use keywords here. Where I can actually use, well, hello guest, welcome to place. Place is a great place, and say see you around next. And I can actually drop this variable. I don't need this. I could actually use a format that says msg.format of whatever keyword you use here within the curly braces. You can use that as a keyword argument. So you could actually now say message.format of guest is equal to Alice, and this time I have to say place is equal to Taj Hotel. Or maybe you want to change the guest and the hotel. No problem. Message.format of guest is equal to, let's try Smith, and place is equal to Hyatt. So you can see that by using the format method in the modern version of Python, that is since Python 3, you can actually get better leverage in templating your strings and substituting parameters there. So when you use these numeric placeholders here, these are called as positional placeholders. So the format method is supposed to be provided just positional arguments. The first argument will substitute wherever it sees 0. Second argument will substitute wherever it's 1. If you pass a third argument, you'll substitute wherever you'll find 2 in curly braces. It's quite flexible. You can pass as many arguments as you want as long as you have that many numbered placeholders in the template. But if you want to use it more intuitively, I would recommend using the keyword based placeholders. So you can use keywords here, right? And you can use keyword arguments instead, which is actually very, very readable. So in terms of readability, I would always recommend the last approach if you can follow that. Maybe the first approach is useful in certain simple use cases. Let's say, as usual, I can create a template like this, where I can just say, you know, number, I can say number format is equal to decimal 0 colon D, binary 0 colon B, hex 0 colon X, and octal 0 colon O. I could also use some hashes to signify the prefix. I think we just learned that in the previous session with the format literal string. So it has the same syntax as format literal string, but instead of using the actual variable, you could use some placeholders like these. So I'm using 0 all over the place. 0, 0, 0, 0, but with different formats, which means that you now just type this number format dot format of, or number format dot format. Doesn't read nice. I'll just make it as number. That's enough. Number dot format of, I can just use a number. Let's say I want to find out what is 65 in all different popular base formats, right? Decimal, binary, hexadecimal, and octal. 65. Let's try that. Well, you can see that. Decimal 65, binary, it's represented correctly, hexadecimal, and octal. This is nice. Now imagine doing this with the old percentage operator. It gets a little too messy. Just want to show you why it's not that great anymore. You need to use it like this. You need to say percentage, you need to use percentage %D. I'm not sure if there's a binary format. I'm going to try it. Percentage %B, does it work? I don't know. Let's try percentage %X. And I don't know whether this percentage %O is supported, but I'm just going to try it. Maybe these are Python extensions. Just want to check. It's been a long time since I've used these format operator, many years. So my knowledge on this is slowly rusting away. But I'll just try to use number percentage. I'll pass the same number again. 65, 65, 65, 65. Pass it all over again. And only then you get the, oh, it doesn't work. Unsupported format, B. Sorry. It's very, very limited, as you can see here, right? So it doesn't support binary format. I don't think it even support octal format. The only thing it can support is decimal, float, and hexadecimal format. So this doesn't work. So you can see that right here. I'm going to leave it at this to show you it doesn't work. Even if it worked, it's not very intuitive. So if you have been using format operator, if you see any old Python code where they use a percentage format operator, time to change it to dot format method if you can, or if you can refactor the code to use format literal strings. That's much more recent. Since Python 3 or 6, it's more intuitive, right? So this is how you can represent formatting. So the format operator is an old school way of formatting strings, just following the C printf style formatting for a string. So this is one operator which I missed in the last session. There are other things I should quickly tell you is about comparing strings. I think I did cover that in the very early sessions, but I'm just going to recap that. Strings can be compared. So you can compare strings. Let's say I'm going to use A comma B is equal to Alice comma Steve. I can print A double equal to B, A not equal to B, A less than B, and A greater than B. I forgot a comma there. All these works. As I mentioned in one of the earlier sessions, that strings are compared lexicographically. That means that you can see that A less than B is true because Alice comes before Steve if you put them in sort order, right? A greater than B is false because obviously Alice is lexicographically smaller than Steve. So it uses the alphabet comparison. So these are things you should know about the string operators. And There's also another operator. I forgot to mention. I think I would have covered that, but maybe you've forgotten. Just putting in one place. If I have a string like this is a test string. If you want to check whether a substring is there in a string, as I already told you, you can use the in operator. I covered this in the Boolean expressions in that session. But just to recap, you can always check for substring's existence in a string by using test in a. That's it, right? So if you want to just find out whether a substring is there in a string without having to worry about where it is, whether it's in the starting, beginning, whatever, no, you don't. You're just checking anywhere. You just want a true or false kind of a answer, then you can use the in operator, right? The opposite of in is not in operator. You can also try something like this. Maybe you can try uh, temp not in a. Well, also written true because there's no word called temp in the string, right? So there's something that you should know about. The problem is this comparison is case sensitive. It is case sensitive. So if at all you want to make it a case insensitive comparison, how do I do that? Well. Okay. One way is maybe you convert the string to completely lowercase and then compare it, but that can be quite costly. I'll talk about that. There's a way to do it by using something called string.collate. If at all you want to do anything like, say, case insensitive comparisons of a string, you need to collate the string first. And that's done by using, let's say, let's try this. We'll just say maybe, s is equal to, and I hate this auto completion. I never meant that, but it's assumed it has that. Okay. And IntelliSense going wrong sometimes. If I now try S in A, it's going to return false. It's not returning true, right? Why? Because though this word test exists, it is not matching the case correctly. Because you can see that there's a small t here, but there's a capital T here. So you want to make this, sometimes you want to search for a substring in a string, but you want to do the search in a case insensitive manner. The complex way to do it is convert both of them to lowercase. Maybe you can just use something like s dot lower in a dot lower. But this might not scale very nicely if you deal with very large strings. Imagine for a moment that you have a string that's got about million characters. Million characters. Let's say A is not just a small string, but it's got a huge data that you read from a file, a very big text file. Maybe you read a complete novel, right? A very big novel or any big book into a single string. It's possible. Today's computers got enough memory. You can slurp an entire file, an entire novel into memory. It's possible. And assuming that you got that entire huge string in memory and you want to search for a substring in a case insensitive manner, one string, one word in the entire 10 million character string. Converting an entire 1 million character string to lowercase is going to be very costly because you're going to create another string that's on lowercase, right? It's an expensive operation. The way you do that in Python is by using something called as collation. You can say s dot, okay, s in a dot collate first. Let's try this. Oh, collate is not there. I'm kind of surprised to see that. A dot, maybe is it called? Oh, okay, it's not called collate. Mistake. Collate is a terminology. It's called casefold. Sorry. Sometimes my knowledge from SQL world spills over into Python. It's called casefold. I just did a auto completion to find out. You say a dot, you can see all these are the different methods, and suddenly look at it, it's just casefold. So you can actually use s in a dot casefold. Oh, didn't work. But you need to do what? Substring you can convert to lowercase directly, convert to one case format, and in a dot casefold. What casefold does is, depending on what kind of encoding you use, it would actually try to treat the uppercase and lowercase with the same value. So uppercase A and lowercase a will have the same value when stored in a numeric format. So it tries to treat with the same form. So it could be a little optimal compared to converting entire string to lowercase and checking it. So if you want to do case insensitive checks and comparison, you might want to use string.caseFold and then compare them, right? That's what you need to do. All right, so I talked about the in operator, I talked about the equality operator, and a little bit more about slicing. More I will cover when I talk about tuple and list, but it's possible in string. So assuming I have a string here, this is a, I'll do one thing, I'll just use something like very ordered string, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Or sometimes I want to do it like this. Maybe I should have had the string ready, but yeah, just bear with me. I know it's cumbersome. I'm just trying to use uppercase, lowercase string, uppercase, lowercase letters together. This can also be generated programmatically, by the way, once I teach you some more interesting features. Uh, there's a kind of string I'm looking at. It's quite organized. You have an uppercase A, lowercase a, uppercase B, uppercase D, lowercase d. It goes up all the way till Z, right? If I now try to get the slice of a string, let's say A of colon 10, so to get the first 10 characters. I could use, I'm just going to print all these things. You have colon 10, print A of, maybe I can try maybe uh, 20 colon. Let's say 20 colon from the 20th index till the end. If you don't provide the start index here, but you provide the stop index after the colon, it's a stop index. Anything that comes after a colon is a stop index. Anything that comes before the colon is start index. So I'm trying to say start from the beginning up to the 10th index. So it extracts the first 10 characters here, right? But when I say start from 20 till the end, that's how we read it, right? So this is like extract, slice the first 10 characters. Here, slice from the 20th character till the end. If you want to get the last 10 characters, I told you, you could use A of minus 10 colon. This is how you get the last 10 characters. This is how you slice the last 10 characters. Or you can also do something like this, where you can say print A of colon minus 10, which means slice until the last 10 characters. You can see the formats being printed here. You can see the first one, the first 10 characters, the second one from the 20th character onwards. The first 20 characters are skipped. Everything after that is what is extracted till the end. That's what you see here. This one is extract from the last 10 characters. So you'll try to go from minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. I think it starts from V, is it? Yeah. This is the minus 10th index from there till the end. It extracts the last 10 characters. But maybe you want to extract everything but exclude the last 10 characters. I want to get only 10 from here to here, right? And that's what colon minus 10 does. And the last thing I should tell you, that slices in Python for all these sequences. You can also pass another parameter, which is the step value, just like in range. You can say A of, I could just say maybe colon 20, for example. When I say colon 20, you can see it extracts the first 20 characters. But if I try to say colon 20, colon 2, get the first character, skip the second one, get the third character, skip the fourth one, get the fifth character, skip the sixth one. It goes on. So it gets every alternate characters. I mean, sometimes say first, second, thirds, but it's like 0th index is fetched, first index is skipped, second index is fetched, third index is skipped. It goes on all the way up to the 20th index. But maybe you want to get the odd elements. I guess you know what to do. You want to start from index 1. So I can say 1 to 20, make it 21, colon 2. Or maybe you want to get every fifth character in the entire string. Oh, okay. I'll do one thing. Before I even tell you about the fifth character, maybe I want to get every alternate characters in the entire string. How do I do that? A of colon colon 2. You can see what string it is, what I showed you in the notebook, and what is extracted here. Every alternate characters till the end, right? This colon colon means from the beginning till the end, get me every step value of 2. Get me items at every step of 2. But you can also do, let's say, get me every fifth character. You'll find a very few elements in here. Might look a little haphazard. You need to go and check it up. After A, skip 5 characters. Again, then it gets small c, skip 5 characters, gets capital F. You can do that. It might look a little scrambled, but when you look at it, it's more orderly based on what elements are fetched from here, right? So you can do all these kind of slice operations on a string. You can do that all even on a list and tuple, which I will show you when I cover list and tuples in the next sessions. So there's something you should know about all these slicing operations. And what else? I think all the operators are completed by now. What you don't need to know about string. There's one missing operator I should talk about, slicing, one interesting nugget, which I'll cover a little later. Now, when you're dealing with strings, you might want to perform certain transformation on strings or do some checks on a string. First, let's look at some validation. Let's say I have a string here. I say the string is made up of numbers or maybe letters here. How do I know it's only made up of letters? Well, I can use a dot is, maybe I can just use is alpha. It's false. You know why? There's a space in here. You remove the space and is alpha will return true. The is alpha method returns true that if every character in a string are made up of alphabets, right? Checks if the string is only made up of alphabets, valid alphabets. Remember, when I use the word alphabets, it's not necessarily English alphabets. It works very well with Unicode. You can also have some Hindi letters. You can have some Kannada letters, or you can have, Tamil letters, anything, or maybe Mandarin, Spanish, Chinese, whatever. It'll work as long as they fall into the category called alphabets, right? So it's Unicode compliant. So that's something you should know about is alpha. There's also another variant where suppose if I just type a is equal to some letters with a number here like this, and obviously a dot is alpha is not going to return true, it's going to return false. This will return true if you tried a dot is alnum. Alnum stands for alphabets or numbers. It's useful for validating user input. Maybe if you're getting user input and you expect the user input to be only alphabets and numbers, only alphabets, you can do those checks by using if condition. You can check user input. Maybe you can do this. A very simple small code snippet where I could just take maybe name is equal to input of enter username, right? And I want to ensure that the username that the user enters should only be made up of alphabets. So say if not name dot is alpha, you can just say print invalid input. Please enter only alphabets. So run this now. For type hello, no problem. Run this again and try maybe H3LLO. Say just prints a message. This could be in a while loop until the user enters a valid keystroke, a valid combination of letters or so on. You don't want to continue. You can put this in a while loop if you want to. You could actually transform this to while loop if you want to, where you could actually do this. while. I'm using the modern Walrus operator syntax. Okay. I could actually use, maybe I can do this. Let's try. Dot is parenthesis not matching. Hopefully. Yeah, I guess we should match this whole block here. You can see it's asked enter username, and while it's prompting for user input, if I type some numbers like say some number, invalid input, please. Okay, I said please enter only alphabets. Sorry for the grammar, so I forgot the word enter there. Okay, so never mind. So you can just type anything else. Maybe if I just put some uh, John space Doe will still not work because it's got a space in it. So if you only type John, then it says welcome John. You can see this. You can read this. While not name is equal to input of enter username dot is alpha. While you get user input into name and that's not an alphabet, not made up of alphabets, keep printing this message. Else, just say welcome the user, right? This could look concise, but some of them could say, no, I like to use the good old while true loop and get input and break out of the loop. Yeah, you can also do that, but this is one of the ways to check this, right? So this is one thing, and this is one of the ways of using the is series of functions. I told you is alpha, is alum. There's much more. You can actually use, if we just say a dot is, you can see a whole lot of them. It's all pretty straightforward. I'm not going to go to every single one of them. I want you to try it out. Is alpha is like checks only for alphabets. Is alum combinations of alphabets, numbers, and underscore. Actually, is alum will work with alphabets, numbers, and underscore. Okay. Is ASCII will ensure that the alphabets fall into the ASCII subset, not Unicode. So it'll only work with English letters. It doesn't work with Unicode. That's what is ASCII is. There's a confusing part called is decimal, is digit, and is numeric. Hang in there, I'll talk about that. Is identifier will check whether the characters fall into the naming convention of identifier. It should start with a letter or an underscore and can contain only alphanumeric characters. It checks for that. Is lower will ensure whether the number is made up of, the string is made up of lowercase characters. And is printable will check for the string being printable character. I mean, space characters are not supported. So as long as you have some printable characters, which are like even special characters, if you want to consider, numbers, alphabets, and all the special characters, but you don't want to include non-printable characters like new lines and tab characters and backspace characters and so on, you can use is printable. Is space will check whether a string is only made up of space character. Not really just a space character, white space character. White space is a combination of space, tab, new line, carriage return. Any combinations of them. It's true when you check that. Is title is just a, I don't know if there's any good use of it. It ensures a string is made up of title case. Like, every word should start with the capital letter. That's what it checks for. Is upper will ensure whether the string is made up of uppercase. So all of these are different is methods to check for strings in different format. Coming to this interesting thing called, not really interesting, is digit, is decimal, is numeric. They all look very similar. I couldn't find out what's the difference between it until some really deep digging. And ultimately, I got an answer when I checked it up, thanks to a fantastic author in Stack Overflow, apparently. But I'll tell you what that is. But just say a is equal to, probably want to make sure a string is only made up of numerical digits. You can try a dot is digit. This will return true only if it's made up of digits. Any non-digit character is going to fail. Remember, it doesn't work with float. You cannot validate whether a number is floating point using any of the is methods, right? You only ensure that's only made up of proper digits in them. So you can say is digit. You can try is numeric. You can try a dot is decimal. All of these three will return true. The numbers, if a string is made up of only digits and nothing else. What was that? Is numeric. I forgot that. Is. So what's the difference between these three? Hardly I couldn't notice the difference. If you've been dealing with numbers which are purely numbers that you can type on your keyboard, normal keyboard, you will not notice any difference. If you're dealing with just decimal numbers from 0 to 9, all three will work fine. But what I learned is that the is decimal, what it checks is a subset. It checks specifically for decimal integers. Decimal number system, integers, right? Is digit, on the other hand, can work with subscript and superscript characters, which are not numeric in nature, but it's in a string. You have a string, it's a string, no matter. But maybe you have a string which got something like 2 to the power of 2. I'll show you that. It's a little difficult to type it, but I sort of remember the Unicode for the subscript 2, superscript 2. So it's like, because I've been training this. So if you say 2, you put a slash u and then put 00b2 and try to print a. So you get a 2 to the power of 2. Remember, you cannot do any arithmetic with this. It's just for print notation, right? But you want to ensure that this, let me just check what was the outcome of a dot is decimal first. This is likely going to fail. A dot is digit. And a dot is numeric. Is decimal fails right away. Is digit, is numeric, both are true. So now you can see that is decimal checks for a small subset of numbers, very small subset, purely a decimal number system, something that you can convert to integer. So if you want to check whether a number can be safely converted to an integer, you should use is decimal. That's it, is decimal. But is digit can work even for some characters which are like superscript characters. Remember, this cannot be converted to integer because you cannot create an integer out of this. Okay, the superscript 2 is not understood by base 10 number system. Let's say is int will not work with it. Int construct will not work with it, right? So you can, but this returns true just in case you want to check whether they are made up of digits. It'll work with superscript and even subscript digits and so on. Is numeric can take one more step forward. It'll also check for fractions. I don't remember the Unicode for fraction, but I have kept some of these messy Unicode characters as is in a file. I call this string number madness. All these are numbers in different number system. Let me take all of these things. Let me just copy all of these for a while in this cell. This is numbers in the Arabic number system, right? Arabic numerals. This is Devanagari numerals, which is traditional Indian. And in India, we had different number systems in different states, right? We have Devanagari, which is popular in the north, and it's part of the Sanskrit script types apparently, and also Hindi. Tamil had its own number system, and some of the letters look like Tamil alphabets, of course. And Kannada, I learned Kannada in my school. I sort of remember that very well. And this Kannada number system that you see here. There's also Gurmukhi, which is somewhat similar to a couple of these things. There are some relations here and there. There's also Bengali and Gujarati and so on. So every state and every language has got its own number system. And outside India, we have number system in Chinese and many other languages. So if you want to verify numbers of these types, I think these all work with is decimal 2. Let's check that. Let's try. Let me run this. All this just creates variables with this Unicode. And if you want to check this now, here below, if we just check, let's take this Arabic, for example. Arabic dot is decimal. Works true. All this first set of series that you see, they work with is decimal. If they work with is decimal, that means they will also return true for is digit and is numeric. So is decimal is the smallest subset, then there's is digit, then there's is numeric. Is numeric is like a complete superset of all kinds of numbers, right? Is numeric is a smaller subset, right? It understands subscript, superscript, but it does not understand some special glyphs like fractions. So this is understood by these two. Subscript, superscript is extra understood by is digit. These are understood only by is numeric. Roman numbers. So if I write things like say Roman dot, like this. If I say Roman dot is digit, Roman dot is decimal, and Roman dot. Okay, is decimal is the smallest subset, right? Let's look at the smallest subset is decimal. And Roman dot is digit, and then Roman dot is numeric. You can see that when you use numbers that fall in this last category, Roman fractions, even fractions, right? You can represent fractions in Unicode. They don't work with is digit, nor do they work with is decimal, but they work with is numeric. So it's like is decimal is a very smallest subset, which works in different languages, but as long as they fall in the decimal number system. Is digit will work with subscript, superscript kind of notation. That's an additional extra. And is numeric works with other number systems like all these exotic number systems like Roman, and I think there are also other number systems that are supported by is numeric. You can look up in Stack Overflow. I'll show you the answer to that. I think I've taken a couple of these glyphs from there, so I'll just show you. Just one moment. Stack Overflow. I'll just do a search. Python is digit, is numeric, is decimal. Yeah, here's where it is. This is the answer I was talking about. This one. You can see all these are shown here. There's so many types, and these are all supported by, I think, is decimal, I guess. This is only supported by is digit. Is supports all these kind of numbers, and there's is numeric supports some more exotic formats like these. Some of them are not even printed on my computer. Anyways, so yeah. Apart from that small subtlety, I don't think there's any big difference. So if you're really looking for numbers that can be converted integers, I think you should look for is decimal. I need to verify that. Let me just try this. Let me just try Kannada numbers I have here. That's like 1, 2, by the way. It's all in the same order, 0, 1, 2, right? So you see it. So let me just try to do this. If I just say A is equal to, yes, Kannada 1, 2, it's 12 in Kannada. 12, they say in Kannada. And you don't know what Kannada is, it's supposed to be a language in South India. So it's a language in Karnataka. And if you've been to Bengaluru, that's a local language there. Yeah, there are different languages in India, by the way. So if we just try int of A, it works. Amazing. I don't know Arabic, but I'm sure it'll work with even Arabic. So if you just try some number, like say I'm just going to take these two digits here, and I should be able to create an integer out of it. So anything that is decimal returns true, you can safely convert to integer by using the int constructor. But is digit and is numeric, they are not compatible. Note that. It works. 5, 6. Yeah. This is what it is. So you can see that what these methods do. A very minute subtlety, which not many people care about, but not many of them might be aware, and I keep forgetting it. I don't really use them, but unless you work with locales or localization, this might not matter. Otherwise, in locales, it might make sense to use it. And yes, I talked about strings and string methods. I told you all the is methods. There are so many is methods, and all of them is to validate the string contents, to check whether they're made up of alphabets, made up of digits, different forms of digits, made up of printable characters, made up of space characters, and so on. All these are these methods, and they're all Boolean methods because they will return true or false based on whether they succeed or fail. The next set of methods I should talk about is transformational methods. Now, these are pretty straightforward and easy to remember. So if I have a string that's made up of different types of characters, a string which has got a mixture of uppercase, lowercase letters, right? So deliberately I've created a string like this. So I'm going to show you the outcome of it. This time I should tell you one interesting feature with format literal string syntax supported from Python 3.7. Not 3.6, 3.7 onwards. In 3.7, for debugging purposes, mostly use print for printing debug messages. Some people do that for developer level debugging, right? There's an interesting helper here. So when you use a format string, normally when you say, when you use curly braces and put a like this, you get this output. But when you type a equals, just put the expression equals, you see the output. Interesting. It says a is equal to something. So if you want to print the output like this variable is equal to this value, this variable is equal to this value, it's very easy to just use curly braces and say a is equal to, comma, b is equal to, comma, c is equal to. It just prints it in a more intuitive manner, which is useful for debugging, let's say. And it aids readability for development and all that. So what I'm going to do here is that I'm going to use some print statements here where I'm going to use f a dot upper equals. A dot upper is a method. I'm invoking a method in a dot upper that's used as an expression there. I'm going to continue in multiple lines like this. I could use multiple print statements, but I don't have to do that. When I open a parenthesis and have comma separated items inside parentheses or any brackets, I can use multiple lines, right? I can spill over multiple lines. A dot lower. As you have guessed, this will return a string in uppercase format or lowercase format. That's exactly what it does. A dot, then you have what we call as title. Title case. You'll see what the output is. A dot, maybe swap case. A dot, capitalize. I think that's about it. I think there are 5 of them. What I'll do is I'll add a sep is equal to /n. Separate them with new lines. See, I'm using multiple arguments to print function. Print is passed with multiple arguments. There's the first argument, the second argument, third argument, fourth argument, fifth argument. You know what? I can even remove the first print function. So I can use a single print function to print everything. It's perfectly fine to do this, where I can actually use f a is equal to, comma. It's a single print function with multiple arguments being passed on. And I will end this parenthesis here. Run this. You can see the output. So you can see that a dot upper converts the entire string to uppercase. It's pretty obvious. And returns a new string. Remember, none of these operations, none of these methods modify the original string. None of the string methods can modify the original string. Strings, once created, you cannot modify them. Okay. More about immutability much later. I keep repeating that. Sorry. So yeah, few more sessions and I'll talk about that. So a dot upper returns an uppercase copy of the current string. A dot lower returns a lowercase copy of the current string. A dot title will give a title case, and you can see what title case does. Every word is capitalized. Every word is capitalized. You can see all the other letters are converted to lowercase, right? A dot swap case will convert uppercase, lowercase, lowercase, uppercase. T is small letter, becomes capital letter. H is small letter, H is capital letter, becomes small letter. You can see that. I was small letter, it becomes capital. So you can see that. It swaps the case. And the A dot capitalize will just make the first letter caps and transform rest of the string to smaller letters. All of these are useful for string formatting, nothing else. So if you really want to generate some report in Python and you want to format string and make it work in some particular format, you could use any of these methods. Upper, lower, title, swap, case, capitalize. 5 methods. They fall in one category. And the next thing I should talk about is string searches. So if you want to search for different parts of a string, let's say I have a string here. This is a test string again. If all I want to find out whether a string starts with a specific word or a substring, I can just say a dot starts with. These I would say are sort of inspired from Java. So Java has this method. So if you worked on Java strings, I think you would have seen a starts with, but just it's in camel case. But here it's all small letters. You can say string that starts with this, returns true. Likewise, I'll use a print again here. Print a dot ends with. This is used to check whether a string ends with a substring. If you want to check whether a string ends with any substring, you can say ends with maybe ing in this case. Yeah, it ends with ing, right? Remember, even if there's a space after that, it's going to fail. See, you can see that it shows false in this case because there is a space here. You should not use any spaces. It just checks the characters exactly. So what do you do if there are extra spaces surrounding the string? I will tell you about that. So you have starts with, ends with, and as you know, if you want to search for a string anywhere in the midst, use in operator. There is no contains method. People who come from Java background will search for, oh, contains. Where is contains? It's not there. It's there in other languages like Java, but it's not there in Python. Why? You use the in operator. So I'm just going to put this here. I just want to check whether a word called test exists in a string. You say test in. It's like one set of operations you can perform. Search for existence of a substring specifically at the start, specifically at the end, or anywhere else in the string. That's what this set of operations or methods do. And the next set of methods are mostly for stripping a string. I'll tell you what that means. Sometimes you have a string that's got lots of spaces here and maybe ends with a lot of spaces. It could be just not just space, but space, tab, new line, carriage return, all these combinations, right? And here I'm going to use a couple of tab characters, a couple of new lines, a couple of carriage returns, a couple of tab characters again. Let me just reduce it so I can keep it within the screen. I'll use carriage return here. But try to print this string. The string looks heavily spaced out, right? I'm going to show you something. What I'll do is I'll use the format string to show you what really happens now. When you use the format literal string syntax, it shows in a more of a representational format here. It shows with quotes. You can say that A is equal to within quotes, the tab characters, there's a string, tab, new line. You can see that, right? There are a lot of white spaces in the beginning. They are called as white spaces because when you print them as is, you won't see anything being printed. You'll see like spaces and lines. And you can see they're also ending with a lot of white spaces. If not, you want to get rid of them, you can actually use a dot lstrip if you want to get rid of leading white spaces. You can also try a dot rstrip if you want to get rid of trailing white spaces. Or if you want to get rid of both leading and trailing white spaces, you could go ahead and say type a dot strip. You'll see the outcome. The moment you say a dot lstrip, the result of a dot lstrip is leading white spaces being removed, but trailing white spaces are still retained. You can see here. But when you say a dot rstrip, it only removes the trailing white spaces, but the leading white spaces are still intact. A dot strip will remove both leading and trailing white spaces. Some of you might ask me, why do they have an L strip and R strip, and strip will do just fine? It's just a minute performance optimization. If you're dealing with some string data, you're getting from some data streams, like say reading data sets from database or any other sources or even files. Sometimes the formatting is, could be that there could be a lot of leading white spaces when you're reading different records, but no trailing white space. Such case, they're only leading white space, just get rid of that. You can use lstrip. If you have sometimes strings you're dealing with which has a lot of trailing white spaces which you want to get rid of, but no, you don't have to worry about leading white space, they don't exist, then you can use rstrip. Strip is required when you have both leading and trailing white spaces. The point is strip is the slowest because it has to look at two sides. Lstrip is also sort of slow, but rstrip is the faster one, right? In terms of performance, I think rstrip is fast because stripping out trailing white space is easy. But stripping out leading white space a little trickier because you have to re-index the string and all that. So it requires some extra effort, right, in terms of algorithm. So that's what it takes. Anyways, I guess lstrip and rstrip would have the same performance. I don't think there's any difference as such because it's all about indexing. You need to know where the spaces stop and you will extract from there, right? You can do that. So I don't think there's a big difference here, but arrow strip will be slightly slower compared to lstrip and rstrip. When you try for large number of strings, use it only when it's inevitable. Otherwise, if you want to just use rstrip, well and good. If you want to use lstrip, well and good. It's like strip is like lstrip plus rstrip put together. Okay. And yes, there's also method chain loading in Python, which means you could do something like this. I mean, the strip is synonymous to this. You can actually use a dot lstrip dot rstrip. Strip is equal to calling this both together, right? So I'm just trying to simulate what it does. Oh, I think I made a mistake here. So I need to put this and this place. Let me fix it. It's same as arrow strip. Arrow strip is equivalent to remove leading and trailing white spaces. It's a two operation approach. That's why it will be a little slower. All right then. So these are some of the strip methods that you should know about. So looks like we are almost going to be finishing an hour. So all right, I'll end this video here today. There's another part series on working with strings where I'll get a little more detailed. We'll talk about features like find, index, count, replace, and so on. And there will be a couple of exercises for you on the next session. So we'll see you in the next one. So if you really like all these concepts I'm covering in the strings, so I guess you have a very clear understanding about different string operations you can perform, all the string operators I covered starting from the previous session to half of this session, and slicing operations on a string, how they work. I also covered a couple of string methods. In summary, I would have covered methods that's got to do with is series of methods. So before is series of methods, I talked about format method, if you remember, string.format. Then after which I talked about case fold method. We'll see the usage of case fold again, revisit them tomorrow, showing you some optimal code. I talked about a lot of is series of methods, is alpha, is alnum, and all these methods and how to use them, and some of the nuances with this digit is numeric is decimal, when to use what, right? We learned that. And I think I talked about all these methods, the case conversion methods, that's upper, lower, title, swap case, capitalize. And then finally, we talked about starts with, ends with, and then we talked about the strip methods. So these are some of the string methods that you should know in Python. String is the only data type that's got large number of methods amongst the built-in types. Amongst the built-in types, string is the only one that's got way too many methods. But then if you know the categories, you will find like 5 categories. So we'll learn 3 of them. 2 more, which I'll cover tomorrow. So once you know this 5 categories, if there's upper, you should be able to recollect there should be lower, there could be title. You rarely use title, capitalize, and swap case, but mostly upper and lower is what I seen used most widely, right? But it depends. And strip method, you'll use arrow strip, and then you have starts with, ends with method. That's another category, right? Tomorrow I'll talk about split, join, index, find, and so on. That's the next video, right? So I think it's midnight now at my time frame, so I think I'll be continuing the next video tomorrow. So I'll talk about split join semantics in string. That's very interesting, and I'll show you some interesting patterns you can do with it and some interesting exercises based on that you can try out, right? I hope you found this video useful. So if you do like this video, as usual, hit the like button. And if you're not subscribed for my channel, please subscribe, because I'm making this series of videos. Once I'm done with the basics of Python, I'll be making more programming videos covering other languages. Um, I'm a polyglot, so I'll be covering more languages slowly once I finish the Python part, Python Trails. And yeah, thank you very much. So next, see you the next one.